The Sahara Desert was once a paradise of rivers and grasslands. This is the story of the Green Sahara, a lost world whose evidence forces us to rewrite history. By the end, you will understand how a landscape can completely transform and what that teaches us about our own planet's future. We will uncover how hippopotamuses swam where there is now only sand, and why ancient artists painted scenes of abundance on canyon walls in the middle of a desert. What does it mean for a place to hold two completely different identities across time? A map of the Sahara today shows a vast, unbroken sea of yellow and brown, a symbol of absolute dryness stretching from the Atlantic Ocean to the Red Sea. It is a landscape defined by what is absent: water, forests, the dense thrum of life, and yet scattered across this immense emptiness are clues that directly contradict its present identity. For generations, explorers and archaeologists venturing into the deepest desert would stumble upon objects that made no sense in their surroundings. They found the massive, unmistakable bones of hippopotamuses, creatures that cannot survive more than a few days without wallowing in fresh water. They picked up finely crafted stone tools, spear points, and grinding stones by the thousands, all telling a story of human activity on a scale that a barren desert could never support. The most baffling finds were not in hidden caves, but lying openly on the surface, as if the land itself was refusing to keep its secret. This is the central paradox of the Sahara, a place that actively preserves the evidence of its own impossibility. To make sense of this, science uses a powerful concept: the paleoenvironment. This term simply means an ancient ecosystem, a snapshot of a world preserved not in photographs, but in the layers of earth, the chemistry of soils, and the fossils left behind. As geologist Dr. Stefan Kröpelin, who has spent decades studying these clues, explains, each of these discoveries is like a single page from a lost book. Alone, it tells you little, but when you start to collect them, a narrative of an entirely different North Africa emerges, one that forces us to rewrite the entire human history of the region. So two monumental questions rise from the sand. First, what powerful natural forces could possibly transform a lush grassland into the world's largest hot desert? And second, what cataclysm or slow change caused that green world to vanish? To answer these, we must become detectives, examining three main lines of evidence written into the desert itself. The geological evidence shows us the ancient rivers and lakes. The archaeological evidence shows us the people who lived there. And the biological evidence, the fossils of animals and plants, shows us the life that thrived. A stunning example is the Tassili Plateau in Algeria. Today, it is a labyrinth of eroded sandstone in one of the most arid places on Earth. But on its canyon walls, ancient artists painted a breathtaking gallery of their world, scenes of people swimming, of herds of cattle grazing on tall grasses, of hippos and giraffes. The art does not depict a hoped-for paradise, it documents a lived-in reality. So we return to that reflective question: what does it mean for a place to hold two souls, to be both a cradle of life and a sea of silence? It means the ground beneath our feet is not a permanent stage, but a changing canvas, and the Sahara's greatest lesson is that no environment, no matter how vast or imposing, is ever truly fixed in time. The answer to the Sahara's transformation is written in the motion of the planet itself. Earth is not a perfect, steady sphere spinning through space. It is more like a slightly wobbly top, and these subtle, rhythmic wobbles and tilts change how sunlight falls on different parts of the globe over immense stretches of time. These predictable patterns are called Milankovitch cycles, named for the scientist who meticulously calculated them, and they are the grand astronomical clockwork behind Earth's ice ages and, crucially, the Green Sahara periods. There are three main cycles at work: The first, eccentricity, describes the shape of Earth's orbit around the Sun, which slowly shifts from more circular to more elliptical over about 100,000 years. The second, axial tilt, is the angle of Earth's pole, which oscillates between about 22 and 24.5 degrees over 41,000 years, influencing the contrast between summer and winter. But for the story of North Africa, the most critical cycle is the third, precession. This is the slow, wobbling rotation of Earth's axis, much like a spinning top beginning to slow down. A full cycle of precession takes roughly 21,000 years, and it changes which hemisphere is tilted toward the Sun during its closest approach in orbit. This shift dramatically alters where the Sun's energy is most intensely felt during the summer months. Climatologists explain that approximately every 10,000 years, this celestial alignment creates a powerful thermal contrast. When the northern hemisphere summer aligns with Earth's closest pass to the Sun, the landmass of North Africa heats up tremendously. This intense heat creates a massive low-pressure system that acts like a giant atmospheric pump, pulling moisture-laden monsoon winds from the Atlantic Ocean deep into the continent. This is the orbital monsoon pump, a natural engine that, when switched on, can turn the Sahara into a verdant savanna. We can see this cycle stamped clearly in the geological record. Sediment cores from ancient lake beds in the heart of the desert show layers of organic, rich mud that correspond perfectly with the calculated peaks of the precession cycle. It is a direct correlation between a celestial dance and the mud at the bottom of a vanished lake. It is vital to distinguish this natural, rhythmic climate change from the rapid, human-driven changes we see today. Milankovitch cycles operate on a timescale of thousands of years, a gradual pulse that ecosystems and human societies could slowly adapt to. Our current influence is compressing changes into mere centuries, a pace that challenges the very concept of adaptation. So consider this profound connection. How does it feel to realize that the slow wobble of a planet, a motion you cannot see or feel, directly dictated where your ancient ancestors could live, farm, and create art? It places human history within a cosmic context, a story written not just on cave walls, but in the very orbit of our world. With this celestial engine now understood, we can look at what it actually built on the ground, the rivers and lakes that once defined this lost paradise. These orbital monsoons did not just bring occasional rain, they rewrote the entire geography of North Africa. From space, the modern desert appears as a monochrome expanse of sand and rock, a place defined by stillness. But when scientists began using radar and satellite imagery that could penetrate the surface, a different landscape emerged from beneath the veil of sand. Etched into the bedrock were the unmistakable, ghostly outlines of colossal river systems and the smooth, dark signatures of ancient lake beds, a complete hydrological network that has been dry for millennia. This is our first and most dramatic clue: the fossil rivers and paleo lakes. Remote sensing specialists describe this technology as giving the land a kind of memory, allowing us to see the scars of water that flowed thousands of years ago. One of the most staggering discoveries is the Tamanrasset River, a watercourse that once carried runoff from the Atlas Mountains all the way across what is now western Algeria and Mauritania, emptying into the Atlantic Ocean. Its buried channel suggests it was a rival to some of the great rivers of today. Confirming these satellite visions requires boots on the ground. Geologists traveling to these spectral river valleys find not just dry washes, but landscapes stamped with the undeniable signature of persistent water. They collect rounded, smooth pebbles that could only have been shaped by tumbling in a riverbed for centuries. They identify layers of fine silt and clay that settled in quiet lake bottoms, and they map out fossilized shorelines, terraces that mark where water levels once stood stable for generations. Perhaps the most compelling testament to this vanished water world is Lake Megachad. In the Chad Basin, south of the Central Sahara, evidence points to a lake that once covered an area larger than the Caspian Sea. At its peak, it was a vast inland sea, a hub for life and human activity. The proof is not just in the geology, but in the biology left behind. In the middle of the Libyan desert, a place now so dry it receives rainfall only once every few decades, archaeologists have uncovered the fossilized remains of fish and crocodiles. Finding these creatures so far from any modern water source is not a mystery. It is a direct message from the past, a receipt for a world that has since closed its doors. So let that image settle in your mind. Can you visualize the Sahara not as a static, eternal desert, but as a dynamic landscape of flowing rivers and shimmering lakes, with crocodiles basking on muddy banks and fish swimming in waters that have since turned to dust? These hydrological ghosts are the silent, stony foundation for everything that came next, the stage upon which a forgotten human drama was set. A core of mud pulled from a dry lake bed is a time capsule, but its treasure is not gold or jewels, it is dust. In the hands of a paleoecologist, this ordinary-looking sediment holds a microscopic forest, a record of life written in grains of pollen so small and durable they outlast stone. This is palynology, the science of reading landscapes through the pollen and spores plants leave behind. Each species of plant produces pollen with a unique shape, like a microscopic fingerprint. When researchers wash and examine these ancient mud samples under powerful microscopes, they find a botanical census of the past. They count pollen from vast savanna grasses that once waved in the wind, from hardy acacia trees, and even from moisture-loving cypress. This is not a landscape on the edge of survival. It is a portrait of a thriving, mixed ecosystem, a direct confirmation that the Sahara's rivers and lakes were surrounded by a rich tapestry of green. The pollen tells a story of stability, of a climate that supported deep-rooted trees and seasonal grasslands for generation after generation. But plants were only part of the story. The same layers of sediment and the surrounding plains hold the bones of the animals that lived in this green world. Paleontologists piecing together this fossil record describe a scene that feels transplanted from the Serengeti. The Green Sahara was home to a spectacular bestiary, including elephants, whose immense molars have been found in the central desert, giraffes, whose long neck bones tell of browsing on treetops, and herds of buffalo and diverse antelopes. These large creatures, or macrofossils, share their resting places with the remains of the aquatic life we heard of earlier, hippos and crocodiles, creating a complete picture of a land where savanna and wetland seamlessly intertwined. An extraordinary example of this convergence of life is the Gobero site in Niger. Here, archaeologists uncovered a serene lakeside cemetery used by early human communities, but the ground also preserved the fossils of very large fish and reptiles, all inhabitants of the same lost oasis. So what does this astonishing diversity tell us? It speaks to a climate of remarkable richness and balance. A landscape this varied, supporting everything from massive elephants to tiny pollen grains, cannot exist under a fragile or fleeting rainfall pattern. It requires a consistent, generous climate, reliable seasons, and a deeply interconnected web of life. This biological evidence does more than populate a map. It gives the Green Sahara a heartbeat, the sounds of animal calls, the rustle of grass, the stillness of a deep, enduring lake. With the stage now fully set, a lush and vibrant world teeming with life, the question becomes inevitable. Who walked into this paradise and what did they make of it? The arrival of humans into this green world was not a desperate crossing, but a natural expansion into a welcoming land. For much of prehistory, the vast arid expanse of the modern Sahara acted as a formidable barrier, but during its lush phases, it transformed into something far more significant, a green corridor. This was not a narrow path but a wide, open region of savannas and river valleys that created a viable bridge. facilitating the movement of early human populations out of the African continent and into new worlds. This period, known as the Neolithic wet phase, turned the Sahara from an obstacle into a cradle, a place where prehistoric societies could take root and flourish. The timeline of human occupation here is a long and dynamic story. It begins with highly mobile hunter-gatherer groups, people who followed the migratory herds of antelope and buffalo, their lives intricately tied to the movements of the game they depended upon. Their presence is marked by scattered campsites and the elegant stone tools they left behind. But as the Green Sahara stabilized, something remarkable happened. The abundance of reliable water and wild food sources, like the grains that grew in the grasslands, allowed for a new way of life. Communities could return to the same favorable locations season after season, becoming semi-sedentary. This stability was a catalyst for innovation. Archaeologist Dr. Elena Garcia, who has studied these Saharan cultures extensively, notes that this environment allowed for experimentation. We see this in the material culture they left behind, a rich archive of their daily lives. They crafted sophisticated microliths, which are small, precisely shaped stone blades often set into wooden handles to create composite tools like sickles or projectile points. They used heavy grinding stones to process wild cereals, a practice that hints at the very origins of food production. And they created some of the earliest pottery in this part of the world, vessels for storing water, cooking, and likely for social and ceremonial purposes. The social implications of this reliable landscape were profound. With less pressure to constantly roam for survival, there was time for deeper social bonds, for the development of more complex technologies, and for artistic expression. We can trace the connections between these scattered communities by looking at the distribution of their toolkits. The discovery of very similar styles of finely worked arrowheads and pottery across hundreds of miles of what is now empty desert indicates something crucial: communication and movement. People were not isolated, they were part of a network, sharing ideas and technologies across a connected green landscape. So we must ask, how did the experience of living in a plentiful, interconnected Sahara shape the identity and ingenuity of these early peoples? It provided a foundation of security from which culture could grow more elaborate, and they left us their most vivid testimonies of this world, not just in the tools they used, but in the breathtaking art they painted and carved onto the very bones of their land. The silent stones of the Sahara hold a voice, and it speaks in color and form. While pollen and fossils tell us what lived in the Green Sahara, the rock art tells us how it felt to be alive within it. Scattered across remote plateaus and sheltered caves, from the Tassili and Ajjer in Algeria to the Caucasus Mountains in Libya, are vast open-air galleries created over millennia. These are not random doodles, they are a deliberate, sophisticated chronicle, a historical record painted and pecked directly onto the landscape by the people who called it home. To understand this art, experts divide it into distinct periods, each a chapter in the Sahara's long story. The earliest phase is often called the Bubalus period, named for the now extinct giant buffalo, Bubalus antiquus, that roamed the wet savannas. These ancient engravings are a bestiary of the wild, featuring elephants, giraffes, rhinoceroses, and other creatures that could not survive in a desert. They depict a world of untamed abundance, a hunter's paradise captured with a powerful, naturalistic style. Then, as the environment stabilized and human societies evolved, the art shifts dramatically into the Pastoral period. Here, the undisputed stars are cattle, vast herds of domesticated, often beautifully decorated animals shown in scenes of herding, milking, and ritual. This shift in subject matter is profound. It marks humanity's transition from simply living within the landscape to actively shaping it, building a society around the care and symbolism of their herds. The scenes painted in these sandstone cathedrals are breathtakingly vivid. We see communal life unfold, groups of people dancing in intricate patterns, likely during ceremonies that reinforced social bonds. We see the daily work of hunting, with archers taking aim at antelope, and most strikingly, we see undeniable proof of a water-rich world. The famous swimming figures of Tassili and Ajjer are a perfect example, showing human forms gliding effortlessly through water, their limbs curved in the motions of a swim. This is not a symbolic representation, it is a direct snapshot of leisure and life in an aquatic environment. To stand before these panels today, in the profound silence of a hyper-arid desert, is to experience a powerful collision of time. The art freezes a moment of prosperity and connection, a community deeply in tune with a generous land. So we must ask, what compelled these artists to invest such effort in documenting their world? Was it simple record-keeping, a spiritual practice, or a deep-seated need to proclaim, "We were here, and this world was ours"? This gallery of stone is their legacy, a vibrant memory painted in ochre and charcoal, preserving the image of their green home just as the long, slow drought began to gather on the horizon. The cattle depicted in these rock panels are not merely animals, they are the central pillars of an entire civilization. During the Pastoral period, these herds transcended their role as a food source, becoming the very currency of life, wealth, and belief. Anthropologists studying these images speak of a possible cattle cult, a system where the animals were interwoven with social status, spiritual power, and cosmic understanding. To own a large herd was to command respect and influence, a form of living capital that could be traded, gifted, or used to forge alliances through marriage. The spiritual dimension is etched into the stone. We see cattle adorned with elaborate ceremonial regalia, their bodies painted with geometric patterns and flowing lines that likely held symbolic meaning, perhaps marking them for specific rituals or denoting their owner's prestige. The ubiquitous dot and circle motif, often placed near or on the animals, is interpreted by some researchers as a representation of the sun, stars, or vital energy, linking the herds to the celestial order. This deep connection finds echoes in the lives of modern pastoralist groups in Africa, where cattle remain at the heart of cultural identity, used in rites of passage, conflict resolution, and as a direct link to ancestors. The art captures the intimate routines of this life too. Scenes of milking show a gentle, practiced interaction between human and beast, a daily act of sustenance that reinforced a symbiotic bond. This entire way of life was made possible by the Green Sahara's most vital resource, vast, open grasslands. A single cow requires acres of pasture to thrive, meaning the societies depicted here were managing landscapes on a colossal scale, their entire economy and culture predicated on the land's endless generosity. One of the most poignant and debated images from this era is the so-called Crying Cow of Tassili. This particular painting shows a large bovine with a distinct line flowing from its eye, often interpreted as a tear. Some see it as a symbol of mourning, perhaps for a lost calf or a deceased herd owner. Others suggest it represents a ritual practice or a mythological narrative now lost to time. Its emotional resonance, however, is unmistakable. It forces us to consider a profound question. If your entire world, your wealth, your status, and your spiritual beliefs were built around these animals, how catastrophic would it be to watch them struggle, to see the grasslands that sustained them turn to dust? This deep, multifaceted connection underscores what was truly at stake when the rains began to fail and the great drying commenced. The art gives us their dreams, but the trash tells us their truth. Scattered across the ancient lake shores and buried in the sand are the humble, broken objects of everyday life, a material diary of the Green Sahara. When an archaeologist sifts through the sediment at a place like Wobble or Nabta Playa, they are not looking for treasure, they are reading a story written in discarded bone, chipped stone, and baked clay. Each fragment is a direct answer to a practical question, a testament to human ingenuity in a land of plenty. The most telling artifacts are those born from the water. In a desert that now holds no fish, archaeologists routinely find delicate bone harpoons and finely carved fishhooks. These are not rare curiosities, they are common tools, revealing a society that relied heavily on the lakes and rivers, where fishing was a staple of life, not a peripheral activity. This is adaptation in its purest form, a technology shaped by the environment. Alongside these aquatic tools, another innovation spread rapidly across the green expanse: pottery. The invention of fired clay vessels was a quiet revolution. As researcher Dr. Elena Garcia explains, pottery changed the rhythm of daily life. It allowed for the safe storage of water and surplus grains. It enabled new methods of cooking, and it may have even been used in early fermentation processes. A simple pot granted a community resilience, the ability to plan ahead and to transform raw ingredients into something more. The settlements themselves show a landscape utilized with intelligence. We find small, seasonal camps nestled by former lakeshores, likely used during good fishing seasons. We discover larger, more permanent pastoral settlements with post holes suggesting sturdy huts, places where communities and their herds could reside for long periods. And we identify specialized areas littered with stone flakes and cores, the workshops where tools were meticulously crafted and repaired. Among the debris of these lives, small treasures speak of culture and connection. Tiny, perfectly drilled beads made from ostrich eggshell have been found by the thousands. These were more than decoration, they were personal adornment, markers of identity, and likely items of trade that connected distant communities. Heavy grinding stones, their surfaces worn smooth from endless use, tell of women processing wild grasses, an act that foreshadowed the dawn of agriculture. And of course, there are the projectile points, elegant and lethal, a reminder that the bounty of the savanna was actively hunted. The site of Nabta Playa in southern Egypt stands as a powerful synthesis of all this evidence. It was a seasonal gathering place for pastoralists, a site rich with pottery, tools, and animal bones, but it also reveals a startling intellectual leap. Here, around 7,000 years ago, people arranged large stones into alignments that tracked the summer solstice sunrise and the movements of key stars. This is not just a settlement, it is an early calendar, an observatory built by people deeply attuned to their environment and the cosmos above it. So we return to the artifacts in the sieve, the fishhook, the bead, the potsherd. What do they tell us about the creativity of these Saharan inhabitants? They reveal a toolkit of brilliant specificity, a suite of solutions perfectly engineered for a world of water, grass, and game. Their ingenuity was not in overcoming scarcity, but in harnessing abundance, and that makes the silence that followed all the more profound. The green world did not vanish in a single season. Its end arrived as a slow, relentless pressure, a climatic vice that tightened its grip over generations. The same astronomical clockwork that had pumped monsoons into North Africa for millennia was now turning in the opposite direction. As Earth's precession continued its 21,000-year cycle, the alignment that brought intense summer heating to the Sahara began to shift. The powerful thermal contrast weakened, and the great monsoon pump lost its force. The life-giving rains, once so reliable, began to falter and retreat southward toward the equator. Climate modelers who reconstruct these ancient shifts describe a process of aridification that was not a sudden catastrophe, but a long-term trend, a descending staircase where each step down was a drier period lasting decades or even centuries. This gradual change was deceptively dangerous because it allowed for adaptation, for hope that the good rains might return, even as the landscape itself began to transform in irreversible ways. The drying was accelerated by powerful environmental feedback loops, natural processes that magnified the initial loss of rain. Here is how that vicious cycle worked. As rainfall became less reliable, the lush savanna grasses began to thin out. With less dense plant cover, the color of the land changed from a dark, absorbent green to a lighter, more reflective brown. This increase in reflectivity, what scientists call albedo, meant more of the sun's energy was bounced back into space instead of being absorbed by the soil. A cooler land surface further weakened the thermal low-pressure system that had once drawn in the monsoons. At the same time, with fewer plants releasing moisture through their leaves, less water was recycled back into the atmosphere to form new clouds and rain. It was a self-reinforcing trap. Less rain led to less plant life, which led to even less rain. The ecological engine of the Green Sahara was slowly starving itself. We can read this tragic transition in exquisite detail from one of the desert's own archives, the sediments of Lake Yowa in northern Chad. This rare, enduring lake preserved a continuous, year-by-year record of the changing climate in its layers of mud. Scientists who have drilled cores from its bed can point to a specific depth and say, here, the pollen from savanna grasses begins to decline. A little deeper, and the dust content in the sediment spikes dramatically, telling of expanding dry land. The core is a literal timeline of loss, showing the lake shrinking, the rivers becoming seasonal trickles and then disappearing entirely, and the relentless advance of sand dunes where grasslands once stood. For the pastoralists living through this change, the world was literally crumbling at the edges of their perception. How would you make sense of such a slow-motion crisis? You might notice your favorite grazing grounds taking longer to recover after the seasonal rains. You might have to lead your cattle further each year to find water, encountering other groups competing for the same dwindling resources. The paintings of the Crying Cow take on a new, heartbreaking resonance in this light. The environmental pressure was now absolute, and it forced the societies of the Sahara to make a monumental choice: adapt, migrate, or face dissolution. The Great Dispersal was not a single exodus, but a long, slow unraveling of a way of life. As the lakes shrank and the grasslands browned, the fundamental contract between the people and their land was broken. For generations, their entire social and economic system had been built on mobility within a green world. But now that mobility turned into a desperate search for a new home. The archaeological record shows this not with a bang, but with a haunting silence. Settlements that had been occupied for centuries were gradually abandoned. The layers of artifacts, the hearths, the pottery shards, and the tools simply stop. At site after site, the final layers contain less material, as if each season saw fewer people returning, until one year no one came back at all. This quiet disappearance is the footprint of a monumental human drama, a forced migration driven by the changing sky. Expert archaeologists studying this period describe it as a diaspora, a scattering of peoples and their cultural knowledge. When these Saharan communities left, they did not travel empty-handed. They carried with them a portable civilization, a cultural package honed over millennia in a challenging but generous environment. This package included sophisticated pastoral skills, the knowledge of how to manage large herds of cattle in diverse landscapes. It included their distinctive pottery styles, which show up suddenly in new regions. And it likely included an intimate understanding of wild plants and early experimentation with cultivation, a knowledge base that would prove invaluable elsewhere. Their dispersal created ripple effects that reshaped the demographic map of Africa. We can trace several probable corridors of movement, highways of survival etched by necessity. One major flow was eastward, toward the one permanent river that still cut through the encroaching desert, the Nile. Here, the theory proposed by scholars like Dr. Fred Wendorf suggests that pastoralists from the western desert arrived in the Nile Valley during its own dry periods. They brought with them new social organizations, their cattle-centric culture, and technological innovations. Some researchers see in this influx a crucial ingredient in the formative stew, that would eventually coalesce into the pharaonic civilization of Egypt, adding a layer of complexity to that iconic culture's origins. Another stream of migrants moved south, following the retreating edge of the monsoon rains into the Sahel and the lake regions of West Africa. Here, their pastoral traditions likely blended with those of other groups, influencing the development of later, powerful kingdoms built on livestock and trade. A third, less documented movement may have been northward toward the Mediterranean coast, where communities could have integrated into existing agricultural societies. This Great Dispersal was the ultimate adaptation, but it was a strategy born of profound loss. It meant leaving behind ancestral lands, rock art galleries that told the story of a better time, and the graves of loved ones. The emotional and cultural cost of this sundering is immeasurable, so we are left with a poignant question. Can we hear the echoes of the Green Sahara in the traditions of peoples across Africa today? The answer may lie in the deep cultural significance of cattle among many Sahelian and East African groups, in certain artistic motifs, or in shared mythologies of a lost, abundant homeland. The dispersal seeded a continent with memories of a green paradise, turning a local catastrophe into a catalyst for cultural exchange and new beginnings far beyond the dunes. This raises a final, inevitable line of inquiry. If this happened once, could it happen again? The story of the Sahara compels us to look forward, to ask what our own climatic shifts might set in motion for populations today. The final, undeniable proof of the Sahara's transformation is archived thousands of miles from its shores. To read this chapter, we must leave the desert behind and sail into the deep Atlantic. Here, aboard a gently rocking research vessel, scientists lower a hollow tube through miles of dark water until it punches silently into the seabed. What it pulls back to the surface is a time capsule of mud, a slender cylinder containing the layered history of hundreds of thousands of years. This is a marine sediment core, and within its stratified depths lies the Sahara's own breath, captured as dust. For millennia, the powerful trade winds have acted as a global conveyor belt, lifting fine particles from the African continent and carrying them on a transatlantic journey. This airborne freight, composed of minerals pulverized by the desert sun and wind, eventually settles onto the calm, cold ocean floor, adding another microscopic layer to a continuous record. As marine geologist Dr. Peter Domenical describes, each core is like a climate tape recorder, with the dust flux acting as the volume knob for aridity. When the Sahara is green and anchored by plants, the wind carries little dust. When it is dry and barren, the volume of dust skyrockets. To analyze this, scientists in laboratories slice the cores into thin sections, dating each layer with radiometric techniques. They then examine the dust under powerful microscopes and with chemical analyzers searching for specific mineral fingerprints. The most telling of these is quartz. Quartz grains are incredibly hard and resistant to weathering, and their presence in vast quantities in ocean sediments is a direct signature of wind-blown desert dust, as opposed to material washed from rivers. The story told by these quartz grains is stunningly clear. For long stretches of the core, the dust layers are thin, indicating a stable, vegetated Sahara. Then, in a band dating to around 5,000 years ago, the record changes dramatically. The dust content increases by a factor of 5 or more, a thick, persistent signal of profound environmental collapse. This is not a local observation from a single drying lake. It is a planetary-scale confirmation. The work done off the coast of Mauritania provides one of the highest resolution records, showing this transition not as a single line, but as a sustained, stepped increase, mirroring the slow, relentless squeeze of aridification we saw on land. How profound is it to realize that the biography of a continent, the story of its lost rivers and the dispersal of its peoples, is written in microscopic minerals resting on the floor of another world. This global evidence locks the local story into place, providing an irrefutable timeline. The desert had truly asserted itself, but its creation left behind one last, haunting mystery, a question not of what changed, but of who remembers the change and how that memory shaped the world that came after. Even the harshest desert cannot erase every trace of its former self. Scattered across the vast emptiness of the modern Sahara are living relics, survivors from a greener age clinging to existence in improbable oases. These are not ghosts of the past, but its direct descendants thriving in isolated pockets called refugia. A refugium is a sanctuary, a place where environmental conditions remain just stable enough, perhaps due to a hidden spring, a shaded canyon, or a high mountain peak, to allow a community of plants or animals to outlast a regional catastrophe. To find one, you might journey to the Hogga Mountains of Algeria, a jagged volcanic massif that acts as a sky island. Here, in sheltered gorges where fog provides precious moisture, you can find the Barbary sheep, a nimble, cliff-dwelling creature whose closest relatives now live in the distant green Atlas Mountains. Its presence here is a biogeographic puzzle with only one solution. It is a relict population, a stranded remnant of a time when its habitat was continuous across a vegetated North Africa. The story is written in their very genes. Biogeographers who study the DNA of these isolated groups can trace their lineage back to the wet period, showing how they became genetically distinct after their populations were cut off from others by the advancing desert. It is a living archive of isolation. The plant life tells an even more dramatic story of endurance. In the Tassili ajjer, deep within protected valleys, you can still find stands of Saharan cypress and wild myrtle, species that are otherwise found only in the Mediterranean basin hundreds of miles to the north. These trees are ancient, gnarled, and incredibly rare, persisting in microclimates that have offered them a tenuous foothold for millennia. They are not desert-adapted in the classic sense. They are moisture-loving trees that have simply never left their last safe harbor. This highlights a crucial distinction in the legacy of the Green Sahara. Some species, like the Addax antelope or the fennec fox, evolved spectacular adaptations to hyper-aridity and thrived in the new desert. Others, like these relict trees and the Barbary sheep, did not adapt to the desert. They merely survived it by finding a refuge within it. A powerful illustration of this concept is the Nabta Plateau in Chad. This sandstone fortress, carved by ancient rivers into a labyrinth of canyons, functions as a biological ark. Within its permanent deltas, or desert springs, exists one of the world's most astonishing populations, Nile crocodiles. These reptiles, which can grow to several meters in length, live in total isolation, far from any major river system. They survive on fish and occasional migrating birds, their existence a direct, living link to the vast lake networks that once covered the region. They have not changed, the world around them has. So what do these living fossils, these prisoners of geography, tell us about the tenacity of life and the fragility of ecosystems? They are a testament to endurance, proving that life clings with remarkable stubbornness, but they are also a warning, for their survival hangs by the thinnest of threads, dependent on a single spring or a specific band of fog. They show us that an ecosystem is not a monolith. It can shatter, leaving behind only fragments of its former glory. These survivors are the final, breathing chapter of the Green Sahara, a reminder that the past is not always buried. It is sometimes hiding in plain sight, waiting for us to understand its silent, enduring story. The silent, sun-baked surface of the desert is no longer the final word. Today, our quest to understand the Green Sahara is supercharged by a suite of 21st-century technologies that allow us to see what the naked eye cannot, transforming empty sand into a digital canvas of lost worlds. This is the era of satellite archaeology, where scientists begin their search not with a shovel, but with a computer screen scanning images taken from orbit. From hundreds of miles above Earth, multispectral imaging sensors detect subtle differences in soil moisture and vegetation that are invisible to us. These spectral signatures can reveal the ghostly outlines of ancient riverbeds or the circular stains of long-vanished livestock enclosures, guiding researchers directly to promising sites without a single step on the ground. One of the most powerful tools in this new arsenal is LIDAR, which stands for Light Detection and Ranging. Mounted on aircraft or drones, LIDAR works by firing millions of laser pulses at the ground. By measuring how long each pulse takes to bounce back, it can create a fantastically detailed three-dimensional map of the surface, digitally stripping away vegetation to reveal the bare earth beneath. In densely forested areas, this has uncovered entire Mayan cities. In the Sahara, LIDAR is being used to map the intricate topography of buried river channels and fossil dune fields hidden beneath thin sand sheets, providing a blueprint of the ancient landscape. On a more intimate scale, ground-penetrating radar is like giving the desert an X-ray. By dragging a radar unit across a site, archaeologists can peer several meters into the earth, identifying the shapes of buried walls, hearths, or even graves without disturbing a single grain of sand. This non-invasive approach is crucial for preserving fragile sites and for planning precise, respectful excavations. The true power of these tools emerges when they are combined in interdisciplinary projects. Geologists, archaeologists, and climate modelers now work together, feeding satellite data, sediment core records, and radiocarbon dates into sophisticated computer models. These digital simulations can recreate how the monsoons shifted, how the lakes expanded and contracted, and even suggest the most likely corridors of human movement during the drying period. It is a form of digital time travel, testing hypotheses against a virtual landscape. Recent discoveries showcase this technological leap. In the so-called Eastern Desert of Sudan, researchers analyzing declassified Cold War-era satellite imagery alongside modern data have identified hundreds of previously unknown archaeological sites, from stone tombs to complex settlement structures, rewriting the map of human occupation in a region once considered a mere blank space. Another poignant application is the use of drone photography to map and document fragile rock art panels. High-resolution images captured from the air create permanent, detailed records of paintings that are slowly eroding in the desert wind, ensuring that these testimonies are preserved for future study even as the originals fade. Beyond mapping landscapes, technology also peers into the lives of individuals. CT scanning, similar to what is used in hospitals, allows scientists to examine mummified remains from Saharan burials without unwrapping them. These scans can reveal details about an individual's age, health, and even diet from the patterns of wear on their teeth and bones, offering a personal story from the communal past. So we are left with a forward-looking question as our tools grow ever more sensitive. What hidden chapters of the Green Sahara might they reveal next? Could AI-assisted analysis of satellite data uncover patterns of migration too subtle for the human eye? Might new chemical techniques extract climate records from a single grain of sand? The detective work is far from over. It is accelerating, promising that the story of this lost world will continue to evolve with every technological advance we make. Buried beneath the sands of Mauritania and Algeria lies the skeleton of a river so colossal it defies our desert-born imagination. This is the Tamanrasset Paleo River, a watercourse often called the River of Giants for its staggering scale. During the peak of the Green Sahara, this was not a mere stream, but a titanic river system, a braided network of channels that some studies suggest carried a flow comparable to the modern Ganges or the Amazon. Its basin stretched over 1.3 million square kilometers, a watershed that could have swallowed several modern European nations. Today, Its entire world lies entombed under meters of sand and rock, a ghost of water in a world of stone. The first hints of this leviathan did not come from the ground but from space. In the 1980s, scientists analyzing radar data from a space shuttle mission made a startling discovery. The microwaves capable of penetrating dry surface sand revealed a deep, sprawling scar etched into the bedrock of the Western Sahara. This was the river's paleochannel, a vast trough carved by millennia of flowing water, in some places an astonishing 500 kilometers wide. The radar image was not of a single thread, but of a colossal, braided floodplain, a testament to seasonal pulses of water that would have transformed the region each year. Confirmation required a return to the Earth. Geological expeditions to the region, led by researchers like Dr. Charlotte Skonixny, began collecting sediment cores directly from this buried channel. What they pulled up was the river's own testimony. Layers of rounded, water-worn pebbles and coarse sands told of powerful currents. Finer layers of silt and clay spoke of quieter periods where the river slowed and spread out into lush floodplains. The mineral composition of these sediments provided a fingerprint, tracing the river's source back to the distant highlands of the Atlas Mountains and the Hoggar Massif, hundreds of miles to the north. This was a river born from monsoons, a continent-spanning artery. Its journey did not end in the desert. Follow the buried channel westward on a map, and it leads directly to the edge of the continental shelf off the coast of Mauritania. Here, marine geologists have mapped a massive, submerged delta structure, a fan of sediment spreading out across the seafloor. This delta is the river's final signature, where it once emptied its immense load of silt and fresh water into the Atlantic Ocean, possibly influencing ocean currents and coastal ecosystems for miles. The river's life was inextricably tied to the rhythm of the Green Sahara. Its flow would have been at its most powerful during the peaks of the humid periods, when the orbital monsoon pump was strongest. It acted as the central nervous system of its region, a permanent lifeline in a landscape that, while green, still experienced seasonal variations. Its banks would have been ribbons of extraordinary biodiversity, corridors of dense gallery forest, reed beds, and fertile silt that attracted wildlife from hundreds of miles around. For human communities, this river was more than a source of water. It was a highway and a magnet for settlement. Its predictable flood cycles would have created ideal conditions for fishing, hunting, and eventually for the wild grasses that pastoralists relied upon. Canoes could have plied its waters, connecting communities across vast distances, facilitating the exchange of goods, ideas, and perhaps even marriage partners. The river unified the landscape, making the Western Sahara not a collection of isolated oases, but an integrated, thriving network. This leads to one of the most tantalizing questions in Saharan archaeology. If the Nile Valley gave rise to the pyramids of Egypt, what monumental expressions of culture might have emerged along the banks of this equally mighty, now vanished river? The potential for discovery is breathtaking. The deep silts of its floodplains are perfect for preserving organic material. Entire settlements constructed of mud, brick, or wood, tools, baskets, and even the remains of boats could be sealed in a time capsule, waiting for a shift in the dunes to reveal them. Could there be ceremonial centers, places of gathering marked by unique arrangements of stone, buried where the river made a broad bend? Might we find evidence of early trade networks, with goods from the interior being transported to a now drowned coastal delta? The River of Giants forces us to recalibrate our understanding of prehistoric North Africa. It was not a marginal land, but a central one, built around a hydrological feature of global significance. Its story synthesizes all our evidence, the orbital cycles that gave it life, the geology that defines its path, the biology it sustained, and the human cultures it nurtured. To stand today on the barren, windswept plateau that was once its thriving basin is to feel the full weight of planetary change, and to wonder what echoes of that lost world still slumber silently beneath our feet. Their story is not only painted on rock or buried in tools, it is written into the very chemistry of their bones. When a bioarchaeologist holds a fragment of ancient tooth or bone from a site like Gobero, they are holding a personal diary, one inscribed not with words but with stable isotopes. These are non-radioactive forms of elements like carbon, nitrogen, and oxygen that become incorporated into our bodies from the food we eat and the water we drink. They act as permanent chemical signatures, a direct link between an individual and the world they lived in. The analysis begins with carbon. Plants follow different photosynthetic pathways, and these leave distinct isotopic fingerprints. Grasses typical of hot, dry savannas known as C4 plants have one signature. Trees, shrubs, and most other vegetation known as C3 plants have another. When an animal or a person consumes these plants or eats animals that ate them, that signature is transferred and locked into their tissues. By measuring the ratio of carbon isotopes in bone collagen, scientists can reconstruct a prehistoric diet with remarkable clarity. A high proportion of the C4 signal points to a diet rich in savanna grasses, either directly from wild grains or indirectly from grazing animals like cattle. A stronger C3 signal suggests more reliance on forest products or certain shrubs. At Gobero, studies led by researchers like Dr. Paul Sereno showed that the earliest inhabitants had isotopic profiles rich in C4 plants and, crucially, in freshwater fish. This chemical data confirms the vivid scenes from the rock art, proving these people were not just living near the lake, they were thriving on its bounty. Nitrogen isotopes add another layer, helping to pinpoint an individual's position in the food web. Higher levels of a heavier nitrogen isotope generally indicate a diet richer in animal protein. In the Green Sahara, this could distinguish a community that relied heavily on fishing and hunting from one more dependent on gathered plants. But perhaps the most evocative isotope comes from oxygen. The oxygen in rainfall carries a geographic signature influenced by factors like temperature, altitude, and distance from the coast. This signature is recorded in the drinking water and ultimately in the phosphate of our tooth enamel, which forms during childhood and does not change thereafter. This turns a single molar into a geographic passport from someone's youth. By analyzing oxygen isotopes in different teeth that form at various ages, bioarchaeologists can trace an individual's movements. If the isotopic signature in a first molar formed around age 3 differs from that in a third molar formed in adolescence, it tells a story of migration. That person likely drank water from different sources in their early life, perhaps moving with their pastoral community as the climate began to shift or following seasonal grazing patterns. This transforms a skeleton from a static find into a biography. We can now ask, did this person spend their entire life by the lakeshore where they were laid to rest, or did they arrive there later in life, perhaps after a long journey from a drying homeland? This intimate data does something profound. It collapses time. We are no longer looking at anonymous remains, but at individuals with distinct life histories who ate specific foods from a specific landscape. How does it feel to know that a single molecule in a tooth can tell us more about a person's childhood home than 100 scattered artifacts? It makes the past startlingly personal, connecting us across millennia through the universal acts of eating, drinking, and moving across a land they loved. This chemical diary, however, would soon record a story of profound change as the menu of the Sahara itself began to vanish. The chemical diary of bones tells us what people ate, but their stories tell us what they remembered. Long after the last lakes vanished and the dust began to blow, the memory of that green world did not simply disappear. It transformed, taking root in the most durable medium of all, human storytelling. Across the cultures that border the Great Desert from the Nile Valley to the Sahel, folklorists and historians have listened for echoes, for myths and legends that might preserve a kernel of geological truth within a shell of symbolic narrative. This is not about finding a literal, factual history book in oral tradition, but about recognizing how profound, landscape-altering events can imprint themselves on a culture's collective imagination, resurfacing for generations as tales of lost paradises, great floods, or punishing droughts. One powerful theme that resonates around the Sahara's edges is the story of a catastrophic drought. In many West African traditions, there exists a recurring motif of a great dryness, a time when the rains failed for so long that societies were scattered and ways of life were forever changed. While these stories are often framed as moral lessons or explanations for cultural practices, their deep time scale and climatic focus are striking. Folklorists who study these narratives note they often serve as foundational myths, explaining why certain groups migrated or how they learned to adapt to a harsher environment. They represent a cultural memory of rupture, a before and after that aligns uncannily with the archaeological timeline of the Saharan aridification. To the north, the Tuareg people of the Central Sahara, masters of navigating the sea of sand, have legends that speak of a very different ancestral homeland. Some of their oral histories reference a time when their forebears lived not around scattered wells, but near vast permanent lakes teeming with fish and surrounded by pastures. These are not descriptions of the oases they know today, but of a lost ecological reality. Similarly, in ancient Egyptian mythology, the vast western desert, what we call the Sahara, held a complex place in the spiritual geography. It was known as the land of the dead, a place of testing and peril, but also, in some interpretations, a place of origin. The concept of a primordial, lush mound rising from chaotic waters is central to Egyptian creation myths. Could this symbolic imagery contain a distant, fragmented memory of a time when the desert was not a barrier of death, but a fertile womb, a green land from which early peoples eventually emerged into the Nile Valley? The key to understanding these connections lies in a careful distinction. These stories are not encrypted history books to be decoded word for word. They are narratives shaped by countless retellings, infused with spiritual meaning and cultural values. A legend about a land turning to dust as punishment for human arrogance is not a scientific report on feedback loops, but it is a profound way for a culture to process and explain a real, experienced trauma of environmental loss. The flood myth found in countless cultures worldwide is another example, a possible shared memory of rapid sea level rise at the end of the last ice age, repurposed into stories of divine reckoning. So we arrive at a reflective and haunting question. When we listen to the oldest stories passed down around campfires and in sacred texts, stories of gardens lost and worlds remade, are we hearing only metaphor? Or are we sometimes listening to the deepest echoes of real events, to the ancestral memory of watching a green home slowly fade to gold, then to brown, and finally to the relentless, beautiful, and terrifying white of the desert sun? This layer of meaning adds a profound human dimension to the dust cores and satellite maps. It suggests that the end of the Green Sahara was not just an ecological event, but a psychological and cultural watershed, a trauma that became mythology, ensuring that the lost world would never be completely forgotten. The debate over the Sahara's end is not just academic, it strikes at the heart of how we understand collapse. Did this world fade with a sigh, or did it shatter with a scream? The scientific community is actively divided between two compelling models, each supported by its own line of evidence, and the distinction changes everything about the story we tell. On one side is the gradual transition model. Proponents of this view point to long, continuous sediment cores, like those from Lake Yowa, which show a stepwise decline over centuries. The pollen record shifts slowly, the dust increases in pulses, but there is no single catastrophic line in the mud. This paints a picture of a slow squeeze where each generation might notice the springs lasting a little less long, the grasslands thinning a bit more, a relentless pressure that demanded adaptation but allowed for it. The other side champions the abrupt change hypothesis. Here, researchers point to different archives like stalagmites from caves in Oman or marine cores from the Red Sea, which appear to record dramatic shifts in monsoon strength within a human lifetime, perhaps as short as a few decades. These records suggest the climate did not just decline. It could have lurched, with the monsoon system crossing a tipping point and rapidly reorganizing. Experts like Dr. Peter Domenical, who has studied these marine records, argue that such abrupt shifts, superimposed on the longer orbital trend, could have delivered knockout blows to already stressed ecosystems. What could trigger such a rapid lurch? Scientists investigating the abrupt model look for triggers that could have pushed a wavering system over the edge. A massive volcanic eruption, like the one that created Lake Toba tens of thousands of years earlier, could have spewed enough aerosols into the atmosphere to cool the northern hemisphere and disrupt monsoon patterns for years. Alternatively, a sudden reorganization of Atlantic Ocean currents could have redirected the moisture supply, starving North Africa of its rains with startling speed. These are not mutually exclusive with the orbital trend. They are potential catalysts that could accelerate the inevitable. The archaeological record offers a confusing and therefore telling testimony. We see evidence of both patterns. At some sites, the layers show a gradual thinning of artifacts, suggesting a slow, lingering departure. At others, it appears settlements were abandoned quite suddenly, with tools and pottery left in place as if people intended to return after a bad season but never could. This patchwork likely reflects reality, where the broad, gradual trend was punctuated by local, catastrophic droughts that forced immediate, traumatic decisions. A pivotal moment in this story is the 4.2 kiloyear event, a period of severe aridity around 2200 before Common Era, that is documented from the Mediterranean to the Indus Valley. In Mesopotamia, it is linked to the fall of the Akkadian Empire. In Egypt, it correlates with the collapse of the Old Kingdom and a time of famine and disorder. Many researchers see this not as a coincidence, but as the final, decisive chapter of Saharan desertification, the moment when the last viable pastures vanished and the desert assumed its modern, absolute form. This global event suggests that the Sahara's transformation was not an isolated incident, but part of a wider climatic reorganization that reshaped civilizations across the ancient world. So we are left with that haunting question: which scenario is more daunting? A slow-motion disaster you can see coming, where hope persists even as options vanish, or a sudden, irreversible change that rewrites the rules of survival overnight? The answer reshapes our view of prehistoric resilience, suggesting it was tested not by one kind of crisis, but by both the relentless press and the shocking break. The most precise chronicle of the Sahara's transformation is not written in stone but in glass. Across the vanished lakebeds of the desert, scientists search for diatoms, microscopic algae whose delicate, jewel-like shells are sculpted from pure silica. Each diatom species is an environmental specialist, thriving only within a narrow window of water conditions, from the cool freshness of a deep lake to the salty brine of a shrinking pond. When these tiny organisms complete their life cycle, their intricate glass shells, resistant to decay, settle to the bottom and become locked in the sediment, creating a sequential log of the water body's entire history. Paleolimnologists, the scientists who study ancient lakes, describe a sediment core rich with diatoms as a high-resolution climate film strip, with each layer representing a frame in the story of a lake's life and death. By identifying which species are present in each layer, they can read the past with astonishing clarity. a community dominated by freshwater planktonic species, those that float in open water, tells of a deep, stable, and healthy lake. A shift toward species that cling to plants in shallow margins hints at falling water levels. The definitive signal of a dying lake, however, comes with the arrival of salt-tolerant diatoms. These hardy specialists move in as evaporation concentrates salts in the remaining water, a clear biological announcement that the basin is drying out. This gives diatoms a distinct advantage over other proxies like pollen in aquatic settings. They are not passive passengers blown in from afar. They are direct residents of the water itself, recording its chemistry and depth with unwavering accuracy. A powerful example of this comes not from the Sahara's heart but from its southern frontier. Lake Bosumtwi in Ghana, a crater lake with a continuous sedimentary record, holds a detailed diatom archive. Its layers show distinct shifts that correlate perfectly with the humid and arid phases recorded in Saharan dust cores and rock art. When the Sahara was green and monsoons pushed north, Lake Bosumtwi reflected stability. When the monsoons retreated and the Sahara dried, the lake's diatoms registered increased salinity and volatility. This demonstrates that the desert's creation was not a local event, but a regional climate reorganization felt across ecosystems hundreds of miles apart. How does it change your perspective to know that the most detailed and truthful log of this planetary change was kept not by monuments or myths, but by countless generations of silent, glass-walled creatures, each one a perfect timekeeper of the world it knew? These microscopic archives offer a clarity that is almost humbling, a billion-piece puzzle where every fragment is a fact. The desert's history is written in cycles, not in a single chapter. Our story of the Green Sahara is not a unique anomaly, but the most recent verse in a planetary rhythm that has repeated itself for millions of years. This is the essential truth revealed by the deep geological record. The Sahara is not a permanent desert, but a dynamically changing ecosystem, a landscape that breathes in time with the slow wobble of the earth. The African Humid Period we have been exploring, which peaked between 11,000 and 5,000 years ago, is formally known as the Holocene Humid Period. It is simply the latest and, thanks to its recency, the most exquisitely documented of these recurring pulses. Climatologists explain that these greening events are locked in step with the Milankovitch cycles, particularly the 21,000-year cycle of precession. Every time this celestial alignment pumps the monsoons northward, the Sahara responds, transforming from a desert into a savanna. Evidence for this cyclical nature is etched into the land itself, layer by layer. In certain stable locations, if you could peel back the surface, you would find a geological layer cake. At the top, you have the artifacts and lake muds from the Holocene period we know so well. But dig deeper and you encounter older, more weathered stone tools crafted by entirely different generations of early humans. Beneath those, you might find another layer of ancient soil, another fossilized shoreline, another collection of tools that are even more archaic. Each of these layers represents a separate green Sahara, a separate window in time when the monsoons returned and life reclaimed the sand. One of the most significant earlier greening events occurred during the last interglacial period, roughly 125,000 years ago. The evidence for this phase, while more fragmentary, is compelling. In places like the Karga Oasis in Egypt, researchers have identified fossil springs and river deposits from this era. The stone tools found in these older layers belong to a different technological tradition, made by earlier human species like Homo sapiens and possibly even Neanderthals, who also followed the rains into a welcoming green interior. The implications of this cyclical reality are profound. It means the Sahara has worn many faces across deep time. It has been the hyper-arid desert we see today. It has been a vast grassy savanna dotted with acacia trees, During particularly intense humid periods, some regions may have even supported patches of wet woodland. There is no single true identity for this immense space, only a series of temporary states dictated by the astronomy of our solar system. This transforms the Sahara from a static backdrop of history into a dynamic participant. It was a pump for human migration, a cradle for innovation, and then a barrier over and over again. Each green phase offered a new opportunity, a new blank slate for ecosystems to assemble and for human cultures to experiment. Each arid phase forced retreat, adaptation, and dispersal, scattering knowledge and people across the continent. So we must sit with that reflective question. If this vast, seemingly eternal desert can naturally bloom again in thousands of years, what does that say about the permanence of any landscape on Earth? It tells us that the ground beneath our feet is not a fixed stage, but a temporary arrangement of climate, life, and geology. The Sahara's greatest lesson is one of profound change, revealing a planet in a state of constant, rhythmic flux, where even the most imposing environments are merely chapters in a much longer story. The Sahara's transformation was not a local event, it was a planetary one. When this immense region turned from a green savanna to a bright sea of sand, it began to act as a powerful climate engine, sending ripples through atmospheric and oceanic systems across the globe. Climate scientists refer to this as a teleconnection, where a change in one part of the world triggers a chain reaction of effects in distant regions. The newborn desert became an active player in Earth's climate, not merely a passive result of it. The most immediate change was a dramatic shift in reflectivity, what experts call albedo. A lush, dark green landscape absorbs sunlight, but a pale desert of sand and rock acts like a massive mirror, reflecting a significant portion of solar energy back into space. This alteration in the heat balance of North Africa can influence the positioning of major wind belts and pressure systems, potentially nudging the entire intertropical convergence zone, that band of rain producing storms that circles the globe further south. This shift may have contributed to strengthening monsoon systems in Asia while further starving North Africa of rain, a feedback loop with global consequences. Perhaps the desert's most far-reaching export is dust. Each year, billions of tons of fine mineral particles are lifted from the Sahara by powerful trade winds, creating vast atmospheric rivers of dust that journey thousands of miles. This isn't just dirt in the sky, it is a vital nutrient shuttle. Climate modelers note that this dust is rich in iron and phosphorus, essential fertilizers for the growth of microscopic marine plants called phytoplankton. When these dust clouds settle over the Atlantic Ocean, they feed immense plankton blooms at the base of the food web, supporting fisheries and influencing the ocean's capacity to absorb carbon dioxide from the atmosphere. Incredibly, some of this Saharan dust completes a transatlantic journey, carried all the way to the Amazon basin. Research suggests that the phosphorus deposited in the Amazon rainforest, crucial for maintaining its astonishing fertility in otherwise nutrient-poor soils, originates largely from this ancient desert. One of Earth's lushest ecosystems is partially nourished by the remains of another that turned to dust. This dusty air itself shapes weather patterns we experience today. Meteorologists track the Saharan air layer, a hot, dry, and dusty mass that forms over the desert and pushes westward over the tropical Atlantic during summer. This layer acts as a natural brake on hurricane formation. Its dry air saps moisture from developing storms, while its strong winds shear apart their structure. The birth of the Sahara, therefore, may have indirectly helped shape the storm climate of the entire Atlantic basin. The connections extend to ocean currents as well. Some paleoclimatologists theorize that the increased dust fallout and changes in wind patterns following the Sahara's aridification could have influenced the strength of the El Niño Southern Oscillation. the periodic warming of Pacific waters that drives weather extremes worldwide. While this link is still an area of active research, it highlights the profound web of interdependence. Even the vegetation around the Mediterranean Sea shows signs of responding to this distant change, with pollen records indicating shifts in forest composition as the vast desert to the south altered regional atmospheric circulation. So we must pause and consider the scale of this interconnection. How does it reshape your understanding of our world to learn that the fate of a rainforest in South America is chemically linked to a desert in Africa, or that the frequency of hurricanes in the Caribbean can be influenced by dust storms born in the heart of the Sahara? This reveals a planet of astonishing intimacy, where a transformation in one continent writes its signature in the skies and seas of others. The Sahara's story, therefore, is not confined to archaeology or geology. It is a foundational chapter in the biography of Earth's climate system, teaching us that no landscape changes in isolation. The story of the Green Sahara is rich with evidence, yet its full picture remains frustratingly incomplete. For every answer we uncover, a deeper question emerges, driving the next generation of research into this lost world. The scale of the transformation itself is still being mapped. While we know the monsoons pushed deep into the continent, the exact boundaries of the green zones at their peak are a subject of intense modeling. Satellite imagery reveals fossil rivers, but how dense was the canopy along their banks? Were there vast, unbroken prairies or a patchwork of grasslands and shrublands? This uncertainty extends to the people who lived there. Archaeologists can count hearths and burial sites, but translating that into an accurate population density is incredibly difficult. Were these groups sparse and widely scattered, or did the richest lake basins support surprisingly concentrated communities, perhaps even semi-permanent villages that have yet to be found? This leads directly to one of the most tantalizing unresolved debates: the nature of their social organization. The breathtaking rock art suggests shared cultural practices across vast distances, but what kind of societies created it? Were they strictly egalitarian bands of kin, or did the abundance of resources allow for the emergence of social hierarchy, perhaps skilled elders or ritual specialists who held greater influence? Some researchers, like Dr. Elena Garcia, point to the complexity of sites like Nabta Playa with its stone calendar, suggesting a level of communal planning and shared knowledge that hints at more structured social forms. Yet, we have found no evidence of palaces, storehouses, or monuments to powerful leaders. The question remains open: were the people of the Green Sahara organized into simple, mobile bands, or did they develop nascent forms of chiefdoms that managed territory and resources? Another profound mystery lies in the fate of the animals they depicted. The rock art galleries are a gallery of ghosts, showcasing species that no longer exist in the region. Why did some, like the majestic Bubalus antiquus, the giant buffalo, vanish entirely from North Africa, while others, like the ostrich, managed to survive the aridification by adapting to the new desert edges? The answer likely involves a tragic combination of factors. Large, specialized grazers like the ancient buffalo required extensive, continuous grasslands. As the savanna fragmented into isolated pockets, their populations would have been cut off and shrunk beyond recovery. They may have also faced increased pressure from human hunters as both competed for dwindling resources. In contrast, generalists like the ostrich, which can eat a wide variety of foods and travel great distances, had a better chance of adapting or migrating to survive. Their disappearance marks a permanent simplification of an ecosystem, a loss we are still working to fully understand. Our technological reach also defines the limits of our knowledge. A major frontier lies beneath the waves of the Mediterranean Sea. We know from sediment cores that colossal rivers like the Tamanrasset deposited enormous deltas where they met the ocean. These now submerged landscapes are pristine time capsules, potentially holding the remains of coastal settlements, fishing communities, or even evidence of early seafaring. Underwater archaeology in these zones is exceptionally challenging and expensive, leaving these river mouths as one of the last great unexplored archives of the Green Sahara. On land, places like the Gilf Kebir Plateau in southwestern Egypt stand as remote and enigmatic sentinels. This vast, isolated massif, riddled with caves and canyons, is notoriously difficult to access. While some stunning rock art has been documented there, vast areas remain virtually unstudied. What ceremonial sites, burial grounds, or unique artistic narratives might still be hidden in its silent recesses? So we arrive at a final, personal question for you, the viewer. Given everything we have explored, from orbital cycles to crying cows, what single discovery about the Green Sahara would surprise you the most? Would it be the unearthing of a submerged village, complete with preserved boats off the coast of Mauritania? The decoding of a symbolic system within the rock art that reveals a complete spiritual worldview? Or perhaps the genetic tracing of a living population directly back to a specific, named individual buried at Gobero thousands of years ago? The search is far from over. Each new tool, from artificial intelligence analyzing satellite patterns to portable DNA sequencers used in field camps, promises to peel back another layer of this mystery. The desert has not given up all its secrets, and the most surprising chapters of this green world may still be waiting patiently beneath the sand. The very panels that tell the story of the Green Sahara are now vanishing before our eyes. A single, priceless painting of a swimming figure, a testament to a lost aquatic world, can be erased in a decade by wind-blown sand scouring the soft sandstone, or in an instant by a tourist's careless hand or a vandal's deliberate mark. This introduces a profound ethical dimension to our discovery, a responsibility that extends beyond curiosity to the urgent work of preservation. The evidence of this lost world is not buried in deep strata. It is often exposed on the surface, making it incredibly fragile and directly threatened by both natural forces and human activity. Cultural heritage managers working in these extreme environments face a daunting task. The sites are vast, often located in politically unstable or inaccessible regions, and the resources for their protection are scarce. The primary threats form a dual assault. First, climate change itself may be altering the delicate preservation conditions, potentially accelerating erosion cycles or increasing flash floods that wash away sediment layers. Second, and more immediate, is human impact. This ranges from illicit excavation and looting of burial sites for artifacts to sell on the black market, to the unintended damage caused by increasing tourism, where the oils from a single touch can degrade pigments that have survived for millennia. An illustrative and heartbreaking example is the damage suffered by irreplaceable rock art sites in Libya and Mali during recent periods of conflict, where the breakdown of governance left cultural heritage exposed and vulnerable. In this challenging landscape, the most vital partners are not foreign archaeologists, but the local communities, such as the Tuareg and Tubu peoples, who have been the custodians of this land for generations. Their deep knowledge of the terrain, their historical connection to the sites, and their presence are the first and most important line of defense. Ethical research today is defined by collaboration, ensuring that projects are conducted with their consent, provide tangible benefits, and treat their traditional knowledge with respect. This partnership is not just practical, it is a moral imperative. Alongside this community-based stewardship, technology offers a powerful tool for preservation. Digital techniques like high-resolution photography and three-dimensional laser scanning can create perfect, immutable records of a rock art panel or an archaeological site. These digital twins are more than backups. They allow researchers to study minute details remotely, and crucially, they ensure that even if the original is lost, its data survives for future generations to analyze and experience. So we are left with a reflective and urgent question. As we piece together the story of a world lost to climate change, what duty do we bear to protect its fragile echoes from our own era's pressures? This is a call to action that transcends academic interest, reminding us that the legacy of the Green Sahara is not just a tale to be reconstructed, but a physical heritage to be guarded with the same tenacity as the relict cypress tree clinging to its last canyon refuge. This ancient story whispers directly into the ear of our modern moment. While the Sahara's transformation was driven by the slow rhythms of a wobbling planet, our world is now changing at a pace compressed by human activity, offering a stark and urgent parallel. The past does not provide a perfect map for the future, but it illuminates the fundamental principles of how ecosystems respond to stress, principles we ignore at our peril. Climate scientists are quick to caution against direct one-to-one comparisons. The orbital cycles that greened the desert operated over millennia, granting life forms and human societies time to adapt, migrate, or evolve. Our current influence is measured in centuries, even decades, a rate of change that challenges the very concept of natural adaptation. Yet, within that crucial difference lies the Sahara's profound value as a climate analog, a natural experiment that shows us how the pieces of a system fall when the foundation of climate is pulled away. The most critical lesson is the concept of tipping points and feedback loops. We saw how the initial decline in rainfall triggered a vicious cycle. Less grass led to more reflective ground, which led to weaker monsoons and even less rain. This is a classic example of a positive feedback loop where a change amplifies itself, pushing the system into a new, stable state, in this case, a desert. Modern climate science observes similar loops at work today, from the melting of polar ice reducing Earth's reflectivity to the thawing of permafrost releasing stored greenhouse gases. The Sahara's history demonstrates that once these reinforcing cycles gain momentum, they can drive change far beyond the initial trigger, and reversing them becomes exponentially more difficult. This brings us to a provocative modern idea, geoengineering. Some proposals look at the Sahara's green past and ask, could we deliberately trigger a new humid period? Concepts like installing vast solar farms to alter local wind patterns or seeding clouds to enhance rainfall are technically imaginable, but they unveil a labyrinth of complexity. Climate systems are deeply interconnected networks, not simple machines. As Dr. Kirsten Schepansky, an atmospheric scientist, notes, attempting to green one region could unintentionally disrupt monsoon rains vital to agriculture in another, like West Africa's Sahel. The cure could be as dangerous as the ailment, reminding us that our interventions must be guided by a humility learned from Earth's own history. This interconnectedness is the Sahara's second great lesson. The desert did not form in a vacuum. Its birth sent dust across oceans to fertilize distant seas and likely shifted rainfall patterns across hemispheres. We see a modern echo of this in the ongoing expansion of the Sahel, the semi-arid belt south of the Sahara. Desertification here is not just a local environmental issue. It is a driver of human hardship, straining water resources, reducing arable land, and contributing to patterns of displacement and migration. The pressures that scattered the pastoralists of the Green Sahara are not relics. They are live dynamics affecting millions of people today, underscoring that environmental stress and human movement are inextricably linked. So we return to that reflective question facing our own climatic challenges. What wisdom can we take from those who lived through the end of the Green Sahara? Their story is not one of defeat but of profound adaptation. They did not stop the change, they read its signs, gathered their most vital knowledge, their tools, their animals, and their stories, and they moved toward resilience. Their legacy is a testament to the durability of culture and the imperative of mobility in the face of a shifting world. In an era of our own making, Their ancient choice echoes as a powerful insight. Resilience may not always mean holding ground, but sometimes knowing what to carry forward when the landscape itself will no longer support the life built upon it. Deep within the silent mountains that border the Great Desert, another archive was being written, drop by patient drop. In the few caves scattered across the Saharan region, the very stone itself grew, recording the sky's history in intricate mineral layers. These formations, known as speleothems, which include the familiar stalactites hanging from cave ceilings and stalagmites rising from the floors, are among the most precise natural chronometers we have for reconstructing ancient climates. Think of a stalagmite not as a rock, but as a 1,000-year-old rain gauge, its growth rings holding secrets more detailed than any sediment core. The process begins with rainfall. When precipitation falls on the land above a cave, it percolates down through soil and fractured bedrock, dissolving tiny amounts of calcium carbonate from the limestone. This mineral-rich water then drips from the cave ceiling. With each drop that falls and evaporates, a microscopic amount of that carbonate is deposited, building the stalagmite upward in layers that correspond directly to the wet and dry periods outside. The true magic, however, lies not just in the layers but in the chemistry locked within them. Geochemists like Dr. Sebastian Breitenbach, who specializes in this field, explain that the water molecules themselves carry a signature. Rainwater contains different stable isotopes of oxygen, and the ratio of these isotopes changes with factors like temperature, storm trajectory, and rainfall amount. When the carbonate deposits from that water, it permanently captures that isotopic ratio. By drilling a tiny, precise core from a stalagmite and vaporizing minute samples with a laser, scientists can read this isotopic signature layer by layer, translating it into a timeline of past rainfall with astonishing, sometimes seasonal, resolution. This makes speleothems invaluable for regions like the Sahara, where permanent lakes eventually vanished. A lake core records a climate history only as long as the lake contains water, but a cave formation can continue growing even as the landscape above it dries, filling in the crucial chapters that lake mud cannot. Some of the most telling records come not from the desert's heart, but from its periphery, from caves in places like Oman, Morocco, and even as far north as Israel's Sorek Cave. These sites acted as remote sensors for the monsoon system. When the summer monsoon was strong, pushing moist winds deep into North Africa, it also brought distinctive, isotopically lighter rains to these borderland regions, which were then captured in the growing speleothems. When the monsoon weakened and retreated, the drip water in the caves changed its chemical signature accordingly. The Sorek Cave record is particularly powerful because it shows a clear, synchronous relationship with events in North Africa, proving that the desert's fate was tied to a climate system spanning continents. So we must pause on that image of a single drop of water falling in darkness for centuries, building a stone tower that would one day tell scientists about the withering of a paradise 1,000 miles away. How does it reshape our sense of time and memory to know that the most meticulous diary of the Green Sahara was not kept by its people or its animals, but by the patient, blind growth of a cave? The savanna grasses that once carpeted the Green Sahara were not just food, they were fuel. Across any landscape rich with vegetation, fire is not a catastrophe, but a natural and recurring force, a partner in the cycle of life and renewal. For the people living within that green world, the crackle of flames would have been a familiar sound, carrying both danger and possibility. This introduces a complex and often overlooked actor in our story, the role of fire itself. Did it simply burn through the landscape as a natural event, or did human hands learn to wield it as a tool, becoming active participants in shaping their environment? The answer lies in searching for ancient smoke, preserved as microscopic flecks of charcoal buried in the mud of long-vanished lakes. Paleoecologists who specialize in this evidence describe their work as sifting through the ashes of time. They take sediment cores from ancient lake beds and carefully wash the samples, looking for tiny, black, angular particles of charcoal under the microscope. These particles are incredibly durable, surviving for millennia, and their presence in a specific layer of mud is a direct signal that a fire burned in the watershed during that period. The quantity of charcoal gives a rough estimate of the fire's intensity or frequency, but interpreting this signal is where the true detective work begins. Were these fires sparked by nature, like a lightning strike hitting dry grass at the end of a rainy season, or were they set intentionally by people? The climate itself creates a fascinating puzzle. Logic might suggest that fires would be more common during dry, drought-prone periods when vegetation becomes tinder. Yet, research from similar savanna ecosystems suggests a counterintuitive pattern. The wettest periods can produce the most fire. This is because abundant rain leads to an explosion of plant growth, creating a massive buildup of fuel, the grasses and dry brush that feed a blaze. When the dry season arrives, all that lush growth becomes highly flammable. Studies of sediment cores from lakes in West Africa, regions that were once the southern fringe of the Green Sahara, show distinct peaks in charcoal during the humid phases. This suggests that the Green Sahara, at its peak, may have been a landscape regularly sculpted by natural fire, clearing out old growth, recycling nutrients into the soil, and maintaining the open, grassy savannas that the grazing herds depended upon. Into this naturally fiery landscape stepped humans with the knowledge to create and control flame. The use of fire would have been a transformative technology. Expert paleoecologists note that distinguishing human-caused fires from natural ones in the charcoal record is notoriously difficult, but we can infer likely practices based on what we know of hunter-gatherer and pastoralist societies. Fire could have been used as a sophisticated hunting tool to drive herds of game toward waiting hunters or into natural traps. It could have been used to clear land, promoting the growth of fresh, tender shoots that would attract grazing animals to specific areas, a form of early pasture management. It might have been used to protect campsites from predators or to manipulate the boundaries between grassland and woodland. This possibility reframes the human relationship with their green home. It moves us from a picture of people simply living within an environment to one where they were actively, though perhaps subtly, managing it. They were not passive inhabitants but agents of change, using fire as a lever to tweak the ecosystem to their advantage. This adds a profound layer of complexity to the story of the Sahara's end. As the climate began to dry and the rains failed, the natural fire regime would have changed. The fuel load would have decreased, potentially making fires less frequent but possibly more intense when they did occur, as the remaining vegetation became stressed. If humans were still using fire for land management during this tense period, their controlled burns could have had unintended consequences, perhaps accelerating the loss of certain plant communities or making the soil more vulnerable to erosion. So we are left with a reflective and ethically nuanced question. If the people of the Green Sahara did use fire extensively, does that make them active landscape managers, consciously stewarding their resources, or unwitting agents of change, whose practices may have inadvertently made a deteriorating environment even more fragile? The truth likely lies somewhere in between. Their actions were born of deep observational knowledge and immediate need, not of a modern understanding of ecological systems. Their story reminds us that the relationship between humanity and environment has never been simple. It is a continuous dance of adaptation, intervention, and consequence, a dance that began long before the first grain of Saharan dust began its long journey across the sea. The true power of this story emerges not from any single clue, but from their convergence. When you stand back and view the evidence as a whole, a startling coherence emerges, like a constellation forming from scattered stars. Each independent line of inquiry, from the wobble of the planet to the chemistry of a tooth, points unerringly toward the same breathtaking reality. This scientific principle is called consilience, the idea that the most reliable truths are those confirmed by multiple, unrelated sources of evidence. For the Green Sahara, the consilience is overwhelming. Picture a timeline stretching back 12,000 years. At the start, the orbital precession cycle reaches its peak, the celestial pump switches on. Almost immediately, deep in the Atlantic, the dust flux in marine sediment cores plummets, telling us the land is anchored by plants. On the continent itself, the lakes begin to rise. Sediment layers in places like Lake Yoa show organic mud, while fossil shorelines etch themselves into now barren plains. The pollen record shifts, registering a surge in savanna grasses and acacia trees. Then the animals arrive, their bones preserved in the mud of those rising lakes. And finally, the people follow, leaving their stone tools by the water's edge, and later painting their vibrant world onto canyon walls. All of these proxies, these separate diaries of the past, rise and fall in perfect synchrony. They are not just telling similar stories, they are different verses of the same epic poem. An expert climatologist might show you a multi-proxy diagram, a graph that stacks these different records on top of one another. You would see the curve for summer solar insolation, the measure of the orbital pump's strength. Directly beneath it, aligned almost perfectly, is the curve for the dust flux moving in opposite direction. Beneath that, the lake level indicators rise and fall. The alignment is not a coincidence, it is a causal chain written in the language of data. Let us focus on a single moment within this green window, perhaps 7,000 years ago. Based on the synthesized evidence, we can reconstruct a day in this lost world. The air would carry the damp, fertile scent of rain on warm soil, not the dry, metallic tang of dust. The soundscape would be a chorus of life, the distant lowing of cattle herds, the buzz of insects in tall grass, the splash of fish in a nearby lake, and the calls of waterbirds echoing across the water. You would feel the humidity on your skin, a tangible moisture absent from the modern desert. Your view would be a tapestry of green and gold, open grasslands dotted with acacia trees giving way to the shimmering blue of a vast lake, its shores fringed with reeds. On a nearby plateau, a community gathers, the smell of smoke from a cooking fire mixing with the earthy scent of clay as a potter shapes a new vessel. This vivid picture is not guesswork. It is the only logical conclusion that fits every piece of evidence we have collected. Of course, minor discrepancies exist, and these are not failures of the story, but guides for the next chapter of research. Perhaps a particular cave record suggests a brief, localized dry spell within an otherwise wet millennium. This does not disprove the Green Sahara. It enriches our understanding, showing that even during a humid period, climate was variable, with good years and bad years, just as we experience today. These subtle mismatches are where new questions are born, driving scientists to collect even finer resolution data to understand the short-term rhythms within the grand climatic cycle. So, having walked through this gallery of evidence, from satellite maps of ghost rivers to the tear on a painted cow, how solid does this vanished world feel to you now? The picture is no longer a speculative artist's rendering, but a robust, multi-dimensional reconstruction, built from a foundation where astronomy, geology, biology, and archaeology all tell the same undeniable story. The Sahara's secret is out, and its truth is built from 1,000 converging whispers. From this barren expanse, we have resurrected a world, a lost world of shimmering lakes, winding rivers, and a tapestry of thriving life now stands revealed, a testament to the incredible dynamism of our planet. This journey has taken us from the silent wobble of Earth's axis to the vibrant scenes painted on sun-baked canyon walls, weaving a story written in dust, bone, and stone. The evidence left behind is now an undeniable portrait, a picture assembled from countless fragments. We have seen the ghostly river channels mapped from orbit, felt the intimacy of a life story told by the chemistry of a single tooth, and listened to the echoes of a green paradise preserved in ancient myth. Each piece, from the vast to the microscopic, fits together into a single, coherent truth. This exploration reveals a profound and humbling connection. The slow dance of celestial cycles dictates the rhythm of Earth's climate, which in turn writes the script for the rise, flourishing, and dispersal of human societies. The story of the Green Sahara dissolves the illusion of permanence. It challenges us to see every landscape, no matter how vast or imposing, not as a fixed backdrop, but as a temporary stage in an ongoing planetary drama. As we navigate our own era of accelerated environmental change, the history of the Sahara speaks with dual voices. It is a stark warning about the vulnerability of even the most abundant ecosystems to climatic shifts, especially when those shifts are rapid. Yet, it is equally a lesson in profound resilience and adaptation. It shows us that human ingenuity, when coupled with deep knowledge of the land, can find pathways forward, even if that path requires difficult movement and the courageous carrying of culture into new horizons. So let this story be a reminder: the ground beneath our feet is not merely dirt and rock, it is an archive. It holds deep, layered histories of transformation, waiting for the curious and the patient to learn their language. These silent stones and buried bones have more to tell us, not just about where we have been, but about the enduring pulse of life on a changing world. If this journey into one of Earth's great mysteries has captivated you, consider joining us for more explorations into the forgotten past. We would love to hear your thoughts. What aspect of the Green Sahara fascinates you the most? Thank you for watching.